Wow, it seems so simple. Healthy forests bring in and trigger their own rain, and most rain comes from elsewhere. So should we be more interested in this elsewhere? And why are farmers, investors, entrepreneurs and policymakers, when it comes to agriculture, forestry and land use, in general not much more busy with elsewhere? For instance, if China realizes that most of their rainfall comes from beyond their borders to the west, even all the way from Europe, would they get involved in restoring farms and forests all the way to Europe? Big ideas, and you could argue it doesn't get much bigger than this. Yes, we're talking again about water cycles, and this time with a professor at one of the most famous agriculture universities in the world, Wageningen. Why has it been so difficult to get scientific discoveries like the biotic pump theory in one discipline like physics to enter the world like climate science and forestry? We talk about the huge pushback the biotic pump scientists have encountered to get papers published and to have it recognized in the past 20 years. But we also talk about optimism and why water is a much easier sell than carbon and why it might lead to a lot more cross-border cooperation. But we have to think really big and get a lot better at working together, which isn't an easy feat. Enjoy this wide-ranging conversation about tropical forests, science, the Sahel, natural regeneration and politics. This is the Investing in Regenerative Agriculture and Food podcast, where we learn more on how to put money to work to regenerate soil, people, local communities, and ecosystems, while making an appropriate and fair return. Welcome to another episode, today with a professor at Wageningen University in forest ecology and forest management, an ecologist, forester, and conservationist. Welcome, Douglas.
Greetings, I'm excited to be with you.
And thank you, first of all, for reaching out and getting in touch after another episode we did on water and water cycles with Rob de Laat, which I will put in the links below as well. And you just did a great conversation with Alpha Lo, a friend of the show, who I will also link below. But we always start here with a personal question. And in this case, definitely an interesting journey, so to speak. What made you spend most of your waking hours focusing, in this case, on forests and the relationship with forest and the full landscape around? Because we're not just going to talk about trees. There will be an important part of this conversation, but we'll talk about rain, water cycles, small water cycles, humidity, and all of that. But what made you spend so much of your waking and maybe also your non-waking hours on this topic?
Yeah, so thank you. I'm a biologist by background, and I think I became a biologist just because biology is, ever since I was a child, just looking for frogs or fish or whatever on the coast. I grew up in Ireland. But the tropics was always the most exciting place, whether you're watching Jacques Cousteau or these BBC documentaries with David Attenborough. The tropics is the exciting place, and just having those opportunities to see these places for real, for a biologist, it's just a wonderful thing. And then, of course, you can't be looking at these places and not concerned about their future. And once you're there, you can't just be concerned about the forest and the animals, but also about the people, because everything is tied up together. These landscapes, it's also about people. So I think I got very much into applied ecology, applied conservation, and that's really been my motivation.
And do you remember the first time, because from Ireland, you're not used to, let's say, the tropics, I'm imagining. I've been in Ireland, that's not true. But at least it's not a tropical country. The first time you stepped into a tropical, let's say, environment and how that was, because you clearly fell in love with it as a biologist.
Yeah, I should say it's a little bit more complicated than that, because my father, when I was a child, he worked his whole career in brewing Guinness, which is about the most Irish job you can have, this black Irish beer that people know about. And he was doing that in Nigeria when I was born. So there's kind of this flavor of travel in the family. And I guess I was jealous of my older sister who remembered it. So I was always going to try and do these trips abroad. And then I guess there was a point in my life where I realized it didn't just have to be holiday trips that I would find sponsors or pay for myself, but actually something that people would potentially, allow me to be a career option.
Yeah, and from the conversation with Alpha Lo, I really remember at some point you switched the tone or the speed, and it's like, this is not just a pessimistic story, this is an optimistic one. And I don't know if that came at the same time you found this paper on the biotic pump, or is that part of the same journey, let's say? Like, what happened when you stumbled upon that specific theory? And of course, slowly it's becoming more mainstream, although it's definitely not accepted across the board. But what happened there?
Well, the bigger picture here is I was working at a research organization in Indonesia and looking at tropical forests and how we can protect forests and also protect the people who live in these landscapes better. What are the opportunities to actually fix these things? And I guess a lot of the stories, a lot of the narratives, a lot of the news you hear about these things, it's often the bad news. And at that time, I was working on a kind of a book. So I guess it's targeted more at students, the values of tropical forest, the issues around conservation. So looking very broadly. And I came across this article by Anastasia Makariva and Viktor Gorshkov. And it was about how forests are actually a major driver of the rainfall patterns. Basically, it's not just that there's recycling, which I guess we already knew about of rainfall, not just the idea that water is emitted from trees, falls again as rain, but there's actually an active process of drawing in moist air from one place to another, and that forests are an incredibly powerful part of this. And I was quite intrigued because I hadn't heard this idea before, and I'm at a global World Center for Tropical Forest Research. You think, well, maybe somebody here has heard of this. So then I ask around, and then a lot of people initially were a bit dismissive or suspicious. If it was true, we would know already, or different kinds of arguments. But you think, okay, nobody really knows. They're just making stuff up. So I was very much intrigued at that point, and I helped promote the ideas because I found them credible. My background, I got a bit of physics in my background from university days. So I was able to at least say, well, it makes sense to me. And I talked later on to Anastasia and Victor. It was also clear that they had already published this in physics journals. So it wasn't as if it was crazy physics. It was actually already peer-reviewed science. It was just very difficult to get it through to the climate scientists. But I guess
in one silo, in one corner of science, and didn't at that point, which is amazing because if like you are in the center of tropical forest research, and you didn't hear about such a powerful concept, if it's true or not is at that point not even irrelevant, but you should at least look at it. And nobody of the people around you asked had heard about it basically and tried to come up with answers to dismiss it, because we would have known it. Yeah,
that's right. And to be fair, I think Anastasia and Victor, these are theoretical physicists. The way they communicate
in Siberia, so it doesn't help.
The way they communicate is to other physicists, and that's what they were good at. Also, to be fair, it's Russians writing in English, so it's very great that they were willing to reach out and try and explain. But they were having real trouble getting through to, I guess, people like me who look at sort of 7 lines of differential equations and say, well, I don't see a mistake, but would I? It's not necessarily my expertise. And a lot of people, I think they just see hieroglyphics on a page, a lot of maths. But the point is, it is peer-reviewed. It wasn't the only article they'd published. They've published a lot of other articles. But this one was just particularly reaching out to people who work in the environmental field and trying to make it accessible. You asked at the beginning about the optimism. I think what with a mechanism like this is it's so powerful that if we actually can keep forests and rebuild forests, restore tree cover, you actually see an awful lot of potential for making parts of the world that are very degraded much more productive again. And I think that was hugely exciting to see that. We see the pattern in the negative version quite widely already. And I had worked in some places or seen some places where the story is quite seriously negative. So I've worked a lot in Borneo, and we've seen serious decline in rainfall in Borneo. Since the 1970s, there's been a huge loss of forest cover and a 20% decline in rainfall. Now, it's a part of the world which has huge rainfall. It's 4 meters of rain per year. So maybe that 20% isn't a huge impact on the agriculture. But if it was anywhere else in the world, this would be headlines, of course. But it's an area where there's huge amounts of palm oil development has taken place. So a lot of those landscapes have changed very rapidly. So we see these big changes. So as Borneo is a sort of a microcosm of what's happening in the rest of the world, we see how dramatic these changes can be in the negative. But the point I would say is trees actually grow back quite quickly, particularly in the tropics. In 10 or 20 years, you can have quite a good forest again. So we can actually recover these things. We can bring the forest back. It's amazing how resilient forests are. There's a very famous area in Java near where I used to live, which is near to the island of Krakatoa. You've probably heard of Krakatoa. This was this...
With a volcano.
Exactly.
Yeah.
So there was this big volcanic eruption over a century ago. But at the time it happened, there was a huge tsunami, a big tidal wave, destroying lots of the forest and everything there. So everything that's grown back is grown back since. And it's just amazing. You go there now. These are rich forests with many species, the birds, the bats, the animals. So it's just incredible how quickly these things can bounce back. And I guess, as I say, I'm a conservationist, so I'm used to thinking long term. It's not just about 1 or 2 years. We're thinking decades and centuries. But yes, there is an optimistic message here. And I think to build on this, if we look in various parts of the world, there's a lot of local people who actually are very well aware of this. There's a lot of people who want to keep their forest. There's a lot of people who want to grow forests in their land. So there's a lot of opportunities here that we often kind of dismiss in the overall stories that we present. So I also work a lot with communities looking at how we can do conservation, or how in many cases they're already doing conservation without any external help. So there's a lot of positive opportunity here that hasn't necessarily been as well explored as it could be.
And so many different angles different routes and journeys we can take from here, which we're going to explore. But just to get back to, you mentioned it's such a powerful concept and such a powerful tool, the biotic pump. We've had Anastasia on the podcast, we've discussed it many times, but for anybody in the back that hasn't heard it yet, can you, as a high school or let's say student level, just to explain to all the listeners that are now thinking or trying to Google or Chat or Claude, what does this mean? Why is it so important to understand not just the sort of passive role of forests that, of course, evapotranspire a lot of humidity, but there is a much more active role between rain and a forest?
Yeah, I think the easiest way, I mean, we won't go into all the physics, I think, but the easiest way to understand it is in the past, we understood, and I guess most people still understand, that the way the winds work on the planet is the air rises over warm areas and falls over cool areas. And basically this has been understood since several centuries, since the time of Isaac Newton and Halley and people. So this was something that was worked out many centuries ago. And that's true, by the way. If you look at
people, we're not gonna display all of this. This is an end. There is another layer.
Yeah. So if you're a sailor and you are sailing along a coast, you know that towards the evening, the air tends to be going into the landscape, right? If you're a sailor at the sea, the wind is always going inland because the air is rising over the warm land. So that draws air in. So that's how we understand circulation.
Because the air goes up and which sort of creates a vacuum underneath it, meaning it starts pulling it from somewhere else because, of course, something has to fill that vacuum.
So the air where it's warm is rising, and as it's rising, there's an entrainment or there's a drawing in of wind or air from elsewhere, and that wind is drawn in. And if it's coming in from over the ocean, that air has picked up some moisture from the ocean, and as it's drawn inland and it starts to rise, the moisture in the air starts to condense and it falls as rain. So the same process we use to understand winds also explains why rain is drawn in from the oceans to the land. But what Anastasia and Victor did is they looked at some of the approximations that have been made. I won't go too much into it, but it's not just about temperature. It's also when the actual moisture in the air is condensing. It also happens when it's freezing. So in droplets or in ice crystals, as these form, there's a change in the molecules in the air. And this is something that people will realize if they've done basic kind of physics or physical chemistry at school. It's just a term that's in there. Everybody agrees it's in there. And in the models, it's considered negligible. It's tiny. It's less than a few % of the effect of the temperature, or that's what people thought. But what Anastasia and Victor said is, well, that was an assumption that was made some decades ago and gave us good models. But what happens if we don't make that assumption? What kind of effects do we see? And what they showed was actually, surprisingly, it can be a very strong effect, this condensation of moisture over wherever it's taking place, actually. But we're talking about over forests here. If you imagine a landscape with forests next to a landscape without forests, the forests are very good at evaporating water. This is just something that trees are good at. They're better than anything else, more or less, at emitting moisture into the atmosphere. And if you emit a lot of moisture into the atmosphere, you raise the chances that some of it will start to condense. So if you have an area where moisture is condensing more frequently, on average, also air will be moving that way. That's basically what the biotic pump is telling us, because you're actually creating a low pressure area with this process.
So forests bring in their own rain. That's the part of their own rain.
Yeah, there's a feedback. So wetter areas bring in more moisture. And people often say, well, is it true of other vegetation too? And I guess locally, yes, any vegetation that would evaporate enough moisture, rice paddy fields, open terraces like in Java or something, you could actually get high amounts of moisture also coming off other landscapes, which would also draw in air that will then rise and you will get the rainfall. So the point is, places that are wet get more moisture. So it sounds very unfair, but if you have a moist place, it actually creates a feedback, and wet places get more moisture coming back.
And that brings up sort of the fundamental question in water cycle restoration or regeneration. Can we trigger that? Can we, with regeneration, with reforestation, with bringing landscapes back to life, predominantly with trees that are the king of evapotranspiration, can we go from a degraded or a not so wet place to a wetter place? And if we do that strategically along from the coast to the mountains or the hills, can you bring in more moisture than you would have brought in otherwise or would have otherwise happened?
I would say to that, absolutely, that's bound to happen. If you took people off the land and just allowed the landscape to recover, it would happen slowly, but it would happen. And in a sense, we know this from history. If we look back in sort of paleo times, the asteroid that destroyed the dinosaurs, whatever, obviously there was a lot of vegetation that was obliterated. And there's been various events of this kind where we see the forest come back and the climate recovers slowly. And in a sense, we can do this. It's at a much smaller scale, luckily. We don't have an asteroid destroying us just yet. But I think allowing nature to do what nature wants to do, we could bring a lot back relatively easily. And to some degree, this is happening in some places already, I think, where people are permitting it to happen. And yeah, sorry.
And why was it so difficult for this to land in other parts of science than just physics? Why was it difficult? Would have been easier, but that's of course a massive assumption, if it would have been a few scientists in Wageningen or in Oxford or somewhere else. And why has it been? It's now coming through. It seems like much more known, but it definitely took a decade plus and took a lot of work from you and of course from Anastasia. Victor no longer is with us. But it definitely was slower than it could have been. Why was there so much resistance from the models that you mentioned? Like somebody questions the model and says, we have the compute power now to do a lot more things than we had a few decades ago. Why don't we try to not just assume? That should have been a basic piece of science. We assume and let's test it, but it's been difficult.
I think there's various answers to that. And I think it partly depends who you ask. I think part of the challenge is that climate science, at least in some countries, I wasn't so aware of this when I was first working on this topic because I was based in Indonesia, where I would say climate scientist is not so political. But when you look towards some of the sort of centers of global communication like the US, it's clearly become a hugely political topic. And if somebody comes in and says, hey, your global climate models are wrong, it's immediately assumed that you have some agenda. It's immediately assumed you're political. You're not who you say you're.
Because why does it affect climate? Like, why does it affect the model there? Because it has a cooling piece.
Well, the point would be the physical mechanisms we're talking about are not fully represented in the models. So we would expect the models to behave quite differently. And we could talk more about this, why I think that is true. But of course, the climate modelers who are used to batting away 100 criticisms every day as just politicized nonsense, they just bat us away as yet another one that they assume is politicized nonsense. And I think that's been my feeling with some of the people I try and talk to, that they're very dismissive. They don't even want to engage it. And I can understand because they get so many non-consequential challenges. And then if I talk to modelers who are actually working on these climate models, try and simulate how the global climate models work, if I talk to them one-to-one, they're actually often quite sympathetic, but they'll say, you know what, we have 150 other concerns that we're also trying to fix in the models. It's not that yours is necessarily less worthy. They're already working on things like Antarctic sea ice, and they're already working on how to properly represent vortices. And there's all kinds of complications they have to deal with all the time. And this to them just seems like another one to add on their list of over 100 items. And the question, of course, is, would it really make a big difference? And I clearly think it would. And I think Anastasia clearly thinks it would. But we really need somebody to take this seriously.
Because how would it make a difference for climate? Locally, obviously, this changes the game when you look at a landscape from an investor point of view, from a farmer point of view, from a food company point of view. Like, this makes forests and forested areas look very different. But why is it important for climate?
I think the opportunity... Well, I mean, there's the negative side to it and there's the positive side to it. The negative side, if we allow deforestation to keep going, we're actually going to lose a lot of productive land that people don't realize we're going to lose. Because so much of the argument has been around carbon dioxide, all of the climate change discussions are around carbon dioxide. And it's not that carbon dioxide doesn't matter. I always have to reassure people, we are not climate, we're not climate change deniers in that way. But it is problematic that currently all the emphasis is on carbon dioxide. And if something correlates, I'm a scientist, it's all about relationships, what you can show empirically with data in terms of patterns. If everything is being fitted to fit with carbon dioxide as good as possible and we're dismissing these land cover effects, then we're not taking the land cover effects as seriously as we could. And I think that's a huge mistake. So we are already losing rainfall in many parts of the world. Like I was saying, 20% in Borneo, but there was also a study out of a group in Leeds published a few years ago showing this is more or less general around the world. Everywhere that there's deforestation, we can predict there's a decline in rainfall. And that in a sense isn't controversial. You don't need the biotic pump to explain that. There's also a recycling effect that if you're returning moisture back to the air, it can fall again as rain. You can have the rainfall fall several times over the land before it washes away in the rivers. But if you don't have the forest returning it to the atmosphere, you get much less intensity of the rainfall cycle. You get a reduction in rainfall. So in a sense, there's nothing controversial there. We should know this, but it hasn't been taken so seriously. But there is a danger, obviously, if the more forest we lose, we can actually tip areas from wet to dry. And that is, it won't just be that these landscapes will become much harsher to live in, much less productive to live in. It'll also be an awful lot more carbon in the atmosphere because the forests themselves and all that vegetation won't be there anymore. But the opposite is also true. If we can protect the forest and restore the forests, restore these wet landscapes, areas which are currently marginal will also become productive again because we'll bring back the rainfall, we'll bring back the vegetation. It will take a decade or two. So it's not something we can do tomorrow, but we have to start soon to be able to see this. And there are positive stories. It's like the greening that's happening in much of the Sahel of Africa. There was a time when I was young when the Sahel was always about disaster. And recently, there's really positive stories out of the Sahel. A lot of farmers are growing trees quite intensively in their fields and they don't see a reduction in their crops. They have a much moister landscape. And some of this is probably just natural climate variation. And some of it is the feedbacks you get from having more trees in the landscapes. So we are seeing some of these processes already. I think for me, when I started at this, the big challenge is how do you do this in landscapes where there are people? And the really nice thing, the West Africa story is, hey, you don't have to worry about it. It's already happening. But to some degree, these things can happen if we allow them to.
This is not a story of we have to remove the people, fence it, and then hope for the best. But there is a lot that can be done on the land with people, and actually a lot that has to be done, or the only way that this can be done is going to be with people, land stewards, peasants, grazers, all of that combined. But just coming back to the climate piece, because with Rob, we also discussed a lot of the cooling potential of healthy landscapes. Is that something that is starting to be recognized or not? Is that still much more controversial? Not just because of land use change. Obviously, you release a lot of carbon from soil, from trees, from shrubs, etc. But also, and you can store if you restore, but also the effects on the atmosphere. There's a potential cooling effect there of healthy landscapes. Is that something you look at, you are comfortable with, or is that a touchy one?
I think, well, for me personally, I clearly believe that's true. I think we're not always very good at joining up the dots. Scientists, we've become a bit over-specialized. And of course, you have to be a large-scale thinker to think outside of these boxes. And this is a danger. It's a bit like the carbon thinking. If your box is carbon, then you're going to fight for your box. But of course, if we should be thinking more about the problems we're trying to solve, which is having a nice planet to live on with all the biodiversity and happy people and production that we need. And then how do we do that? How do we achieve that? And I think for sure, a lot of this is about keeping trees and forests and natural habitats on the landscape. It's not just about conserving things for rare beetles or whatever, but there's really a human welfare aspect to this, which we should be emphasizing much more. And it would be really nice if the policymakers would listen. I have to say, a lot of colleagues, particularly older colleagues who I talk to, are quite sympathetic. But I think a lot of these international initiatives, it's a bit like steering an oil tanker, right? It's hard to to adjust the course, to make all these processes take account of a whole new kind of angle. Yeah, that takes a lot of time. It takes enthusiastic people who are willing to really pick up and run with it. And I feel I've been pushing this quite a long time now. Rob DeLay has been pushing it, obviously. Anastasia has been pushing it. There are some of us, but we're just 3 or 4 people. And the carbon juggernaut is in full swing and it's charging forwards. It's hard to be heard sometimes above the noise of the engine, I would say.
And has that been, definitely not an electric engine, no, but has it been changing? Do you feel that this has been landing differently over the last couple of years? We've been looking at water cycles probably for 8-9 years, of course, with a small podcast, not that we have a huge megaphone, but since the time Walter Jenne and others, Didi Pershaus, like others that have been arguing quite actively, it seems to be mostly in that little bubble. But it also feels like the last year or two, maybe it's just my Substack bubble and the people I read that it's growing, but it seems to be slightly changing the tone. Do you have that feeling as well, or is it just my bubble?
I think slowly. I think for us, and I know I talk to Anastasia regularly in the past about this, it is frustratingly slow, but it is progress. It is progress. I think one time we had an article where there was Anastasia was talked to and I was talked to, and she was quoted in Science. I think it was considered slightly rude, but she said science sometimes progresses, but one funeral at a time. And the problem is when the senior people become dogmatic, that they're not willing to listen to new ideas. And that's definitely seems to be part of the issue. But as I say, it's also the politics. I think the politics has made things polarized. People don't take each other at face value, and this gets in the way of the science. Science is always about debate and discussion and doubt and argument, and that's creative. But in this case, people are just batting away the criticism rather than listening. So that's a shame. And I think also because maybe that Anastasia and Victor obviously came from Russia, and maybe that's not the ideal place to be coming from at the moment. But yeah, it makes things challenging. I think they've done a great job of trying to communicate more widely, and I've tried to help them with that. And I do think we have made a lot of progress. A lot of younger people seem to be open-minded about these things. But then when they look for opportunities for funding and stuff, it's not so easy. And particularly, I work in a university. I wouldn't necessarily give a PhD student or something this as a task, because it's just too difficult to navigate politically, I think. You want to give people things where they would feel quite safe, whatever answer they come to, that they'll have something useful and publishable. And a topic like this, yeah, people get provoked by it. I think there's very strong views, sometimes from surprising directions, I would say.
What's the most surprising one?
Well, just people who are immediately dismissive. I think people who I think of as good scientists, I shouldn't name names, but people who I think of as good scientists.
We'll edit them out.
And I've done this a lot. I've gone and knocked on doors and tried to talk to people or sent emails and said, hey, could I discuss this with you? And some people are open-minded and will talk privately. But some people don't want to talk about it at all. They see it as almost toxic. It's like saying that you've been, I don't know, abducted by aliens or something. It's been an embarrassing thing to admit that you've considered that the biotic pump could be true.
This is when the conversation took a very interesting turn. So tell me about the UFO experience. Now, it's a fascinating point.
Yeah.
And I've been wondering, my hope is that, let's say, the entrepreneurs and investors and farmers who are maybe that don't have the luxury, they cannot be too dogmatic, otherwise their investment will fail, their company will fail, and or their farm will fail, will come to the realization that even the biggest farm or the biggest piece of land you manage is never going to be big enough to manage to influence. You influence on a local scale, but the landscape and the watershed and even the weather around it. But so you have to think at a larger scale, and you have to act at a much larger scale to be able to navigate the next 20 years, which are going to be climate shocks left and right, behind you, in front of you, like you can't imagine. But I'm being really surprised how little this idea of, okay, we have to be very strategic of where we regenerate in a landscape, and we have to be very strategic in terms of thinking, how do we move water up the mountain literally, or how do we bring it to where it needs to go, or where we need it, and how do we recycle it multiple times. That's been also with funders and investors, and we've done 2 or even 3 water cycle series or landscape scale regeneration series. It's been a journey to educate people. Look, this is not sci-fi. Like, we know we influence this. The question is how much, how little, where do we start, how do we use the compute power we have now? How do we model this? How do we calculate? How long does it take? 10 years, 15, 20? These are not impossible for finance because we do that all the time with solar panels. But it's been surprising how little the uptake has been, and now I see a few entrepreneurs that saying, okay, how do we put these pieces together in this puzzle? Because if I invest in a farm, I would love the whole landscape to move forward or to regenerate, because it makes my life a lot easier, just as you want your neighbors not to spray all kinds of stuff. Like, you are part of a bigger system. But it's been, I'll get off my soapbox now, but it's been a journey. But my bet is it's going to move in certain landscapes with people putting pieces together that can't afford not to do that, because otherwise their livelihood will suffer. And then we're going to figure out finance mechanisms and all of that, and agreements across borders, which you mentioned with Alphalo as well, which is going to be fascinating if we have North and South of Europe suddenly arguing about how do we get more water on the land, in the land, instead of arguing about all kinds of other payments. But it's been, most people are like, water, interesting, irrigation. No, it's different. It's about rain and patterns like that. So if you are working on something, listeners, please get in touch, because we just need to really, start yesterday, as with all good tree planting projects.
And what would be your message to, I love to ask, let's say we do this in a theater, maybe in Wageningen, maybe Amsterdam or some kind of financial capital nearby, and the audience is full of investors and people managing wealth, either their own or maybe pension wealth or a bank. And we do a full evening with a lot of nice imagery on stage, like very visual. Maybe we bring people to a tropical forest with nice glasses on, etc. But people also forget, like the next day, what do you want them to remember? What would be a seed you want to plant in their mind if you had that power to do?
Yeah, it's a great question, because I'm often thinking, what's the easiest way to encapsulate this? And I think what I would say, it's so much easier to engage people about water than, for example, about carbon. Everybody,
that's why I'm like, how does that not land yet?
Everybody everywhere cares about reliable access to water. And a farmer in a remote part of Africa or in a remote island in Indonesia, everybody cares about that.
Or in Ireland.
Yeah, exactly. And just the floods or the droughts, this impacts everybody. Carbon is a difficult pitch. Carbon is a difficult sell.
You can't see it, you can't smell it.
But water is an easy one, I think, because everybody cares. Everybody knows why it matters. You don't really have to stop and explain in detail what you're talking about. And the idea that vegetation has some impact on water, this is also very intuitive for most people in most places. Frustratingly, perhaps it's the climate modelers that are the most difficult to persuade. But anyway, let's step aside from that. The point would be also to show how there's a lot of synergies here. If we could fix water, we can also fix many of these other issues. So the carbon would naturally be much easier to fix if there was more water for all the carbon we want to grow. The trees, we could grow over much larger landscapes because there'd be more rainfall, so that there would be less limiting of water. The biodiversity, which initially motivated me to get involved in this topic, the amazing biodiversity in tropical forests. Of course, we need forests for that as well. So there's a lot of these big kind of global concerns. And also showing that you can actually increase productivity in landscapes with trees. You don't have to have a cost from trees. I think that's probably what I would also emphasize if I had enough time, that there is a lot of misinformation out there. And this is something I've been talking about quite recently also with colleagues, because unfortunately there are some simple slogans out there which are wrong, which is that trees always use water, therefore trees always cost water. And of course, it can be true if you grow a big stand of eucalyptus trees in a dry landscape. Yeah, it will dry.
Or palm oil in Borneo.
Well, it will dry out, but you also get other effects. And a lot of these effects we've known about for a long time, but I think people find it easy to dismiss them because we don't emphasize them enough. And I think an example I often use, which is really nice, is a study we published just in 2016. So it's less than 10 years ago. So this was a study in Burkina Faso. So this is a dryland country in Sahel.
West Africa, above Ghana.
In West Africa. And a landscape where most of the people, or at least most of the women, are spending much of their lives walking around to carry water from wells, really deep wells, very difficult manual labor just to get the water you need. And in this landscape, people assume more trees means less water. And it's a very denuded landscape already. There's a lot of hoofed animals and goats and stuff walking around. But what we were able to show with the measurements, I didn't do the measurements, but really painstaking work for several colleagues for several years, and showing that actually having the right amount of trees in these landscapes, and we're not talking about dense tree cover here, we're talking about scattered tree cover, it's a dry land environment, could improve the infiltration several fold. So the amount of infiltration of water, the capture of water in that soil profile went up by several 100%. And as I say to people, we're not talking about 10%, 20%, we're talking several 100%, maybe 500% was the estimate we had, maybe 600%. But this isn't a small effect. This was a huge effect. And it's something I think people have seen. So it's bizarre. We even had trouble publishing it because reviewers were skeptical. Oh, but we all know that trees cost water. It's frustrating sometimes that people get stuck in a certain mindset. And I think it's still a common mindset. Because, okay, we published this 10 years ago, but I think a lot of people would like to say, oh yeah, maybe that one exceptional place, that was what they found, but it's still not true generally. And no, we think this is probably true in many places.
The native tree cover, not the plantation type.
Exactly, scattered tree cover in this case, but it improves the infiltration. It's also true that other measures can also improve infiltration, other vegetation or creating kind of bunds and ditches and stuff. There are earth working methods. But trees have other benefits that you want. They have fuel, they provide fodder, shade and fruit. There's lots of reasons we would want trees. So why not use trees to do this? The point being this positive effect was even disputed at that point.
Wow, yeah. Which just wonders like how long it will take for more and more people to get on board with that. The role in landscapes is not just reforestation and regeneration, it's actually restoring these guys. You can bring back the rains, like you can influence, you can, and it might take a decade, but a decade is nothing if you plant almonds for a living, or like this is like most farmers are used to think multi-generational in many places, and it's just mind-boggling that it hasn't landed yet to a certain extent, that people are still like, oh, that would be interesting. And no, that's actually like, it's published, there's a lot of research, we better get on with it, and we'll better figure out ways to plant strategically at scale, or to preserve at scale. And what would you do if you would be at the other side of the table, if you had a significant investment portfolio? Of course, we're not giving investment advice, I'm not looking for exact euros or dollars amount, but I'm interested where people would prioritize, people deep in the space like yourself. If you had, in this case, we like to say €1 billion to put to work. So this should come back at some point, but could be extremely long-term, 50, 100, 7 generations, that doesn't matter. But it's meant as an investment. Where would you start? What would you focus on?
The opportunity I see is quite a real one, I think, in many parts of the world, but probably the most obvious place would be somewhere like dryland Africa, where I think the natural vegetation was much more tree cover. The communities of people themselves are aware that the trees can be beneficial, and then going into work in these landscapes to bring back extensive large-scale tree cover. And then we would have to think strategically how to do it. But to show that this can work, I think doing it somewhere where we don't have to sell it too hard. I think there would be a general agreement of the value of trying to do this. And I think many of the African countries, you are seeing that they're probably more aware than the Western countries, the significance of water, the significance of trees to local livelihoods. I don't necessarily think that needs to be a hard sell. But then actually trying to think how we do this realistically, what kind of management interventions. I'm not so keen on planting when we can avoid it. So thinking about natural regeneration, I'm much more on the conservation side. Natural vegetation is what is best adapted to most of these systems. It has evolved in these areas. It's a product of these landscapes. There's many sort of specific ecological phenomenon, which you can't necessarily just expect one tree taken from one place to another place to provide those services and values. Yeah, working somewhere like West Africa. I mean, there's maybe easier places in terms of administration, maybe places like Western Australia, where a huge ranch from a couple of landowners who may be already on those kinds of scales we're talking about. But we would want to vegetate, bring back forest tree cover to several hundred square kilometers to show that we get a rainfall benefit with natural vegetation. Maybe thinking about how these landscapes can still make a profitable living for the people who live there. It's easy enough in these landscapes, which are reasonably sparsely populated, maybe to think about how we might do that. But there's a number of these very dry places that shouldn't be so dry. And I think that's an opportunity.
And so how would you go about, and let's say West Africa, how would you, because $1 billion is a lot, but it's nothing at the same time. And how would you strategically pick the places to almost like acupuncture points? What are the steps? Because you have to prioritize something.
Yeah.
How would you figure out where to plant, what and why, or where to restore, or where to preserve, or where to, let's say, intervene and where not?
I mean, there's all political parts to this as well. You have to find the agreement, but let's assume that's the easy part. The technical part is, I think, thinking in terms of this large connected landscapes. We really want to see vegetation as being a little bit like a vast conveyor belt bringing moisture inland. So you really have to think on these large scales from the coast right into the interior. There's this great green wall project in Africa at the moment, which is this little sliver of green. And of course, it's expanded a bit in some places. But rather than just having a wall, we would want to have a huge band coming right the way in from the coast, with as much tree cover as possible, as much natural vegetation as possible, probably trying to include good blocks of existing natural vegetation within that as seeds to refeed species back into these landscapes. because I do want to underline that I think the native vegetation is what we need to be restoring. We haven't really explained why, but things like most vegetation in these dryland tropics, there's a certain time in the year they green up and they use moisture, and then there are other times of the year they drop their leaves, for example. And to actually have the right timing where that's the correct behavior is one thing for that plant. But that greening up also has an effect on the climate locally. So we believe that greening up, say in advance of the rains, is actually a key trigger in creating the rains or the monsoons or whatever with these seasons.
Oh, let's double click on that. So you're saying, I know you're saying this because I've heard you say it before, but these plants, they use the last bit of moisture they have waiting for the monsoon to green before the monsoon even arrives, before we even feel the rain, before we see it. And that actually brings in the monsoon. It's not just, oh, I'm greening up now to be ready. No, I'm actually greening to be ready. And I know I'm going to be ready because I'm partly triggering, or as a plant, I'm thinking as a plant or a tree, but I'm partly bringing this in. So there's an active relationship between plants and trees and the monsoon, and not just I'm passively waiting for some drops, please.
Yeah, no, I think that's right. The word passively often comes up because climate modelers tend to treat vegetation as if it's some passive little component in their model. But we want to say, no, vegetation is an active player in creating the climate we have and the rainfall system.
We just lost the last few climate modelers that were listening. No, I'm sorry.
No, but I think people are aware of this complexity. So the greening up is something that plants will do. And in many parts of the dryland tropics, you get this kind of synchronized greening up in advance of rains. And of course, it's also terrible if the rains don't come at that point. So this is a kind of a dysfunction thing. But in terms of the opportunity, we need to create vegetation again, which greens up at the right moment and doesn't emit water away at a moment where it can't trigger the monsoon. So that's one. Another thing we haven't talked about yet today is when moisture condenses in the atmosphere, it's actually quite difficult to get pure moisture in the air to condense. And what actually mostly happens in the weather system is there are tiny particles. There are just tiny particles in the air which help create these condensation nuclei, they call it technically. But these particles, a lot of them are actually emitted from vegetation. And it's
specifically trees, right?
It's specifically trees, but also other organisms as well. So fungus and stuff. Yeah, there's all kinds. And it's a hugely complicated subject. We're talking thousands of different compounds, thousands of different kinds of particles. They all have their own origins, their life cycles, and what they do when they're in the atmosphere. So this is complicated. But if you
Another argument for native vegetation.
Yeah,
basically.
exactly. So the point is the vegetation produces what we call these particles, or the compounds that help these particles make water condense. And this also has a big impact on rainfall. And this is something we're beginning to understand better, at least that it happens. And maybe it wasn't so well understood in the past. But it's such a complex thing. We're not going to understand it fully in the next decade or so. I think it's just too complicated. But
importantly, that's not an argument to not act now, because we know it works. We just don't know how and how much. But let's not postpone this further, because let's just do a bit more research. Let's do a bit more. No, this is not an argument for no action.
No, it's an argument also for not replacing what we know works, which is the native vegetation, with something different, which produces a very different compound. So like palm oil is grown in these huge oil palm plantations, and this just happens to be something I've studied. And oil palm plantations are a major source of one of these compounds called isoprene, which is very much involved in this rainfall nucleation process. It also makes a lot of smog in Asian countries that are nearby. So it's very much a compound that influences the atmospheric chemistry and what happens in terms of water condensation. So we know these things have an influence. We know they have an impact. But we can't just swap out this group of trees for another group of trees without knowing about this stuff. So it's actually probably an argument for being cautious. And seeing as we know nature works, replace nature at your peril, I would say, because it's complicated.
And is that an argument for, let's say, a lot of these intensive tree crops exist in many places, are expanding as well? Portugal is an example, Spain, Italy to a certain extent with olives, and other places as well, to integrate as much biodiversity and as much other species as possible, because it's a very profitable model with all the issues there are in terms of pesticide or herbicide use and of course labor abuses and that. But I don't think we're going to stop the super intensive train anytime soon. But there are, and we've had a long episode with Dimitri Tsitsos on that, like how far can we push it, and can we have not the same but a similar effect if it's not just a monoculture of olives or a monoculture of almonds or a monoculture of any, like how far can we still have a productive landscape in terms of profit because we need to, or the owners need to, but also push it in terms of different species and thus creating a similar effect, of course not the same as a forest, but a similar effect? Is that because then probably the owners are interested as well, because they need the water, they need the rain, they need the pest reduction, they need the biodiversity for all of those functions, like the functions that you wrote a book about. Is there, in the agroforestry space, let's say, a middle ground there?
I think there's lots of questions there which still haven't got concrete answers, but the cautious side, and as I say, I come from a conservation background, I'm always going to say I think nature knows how to do this best. So we need to really follow nature as far as possible. There's all kinds of services which maybe people don't necessarily think that carefully about, which we only value once they're gone. And maybe the rainfall is one of these, but it's also things like pollination. We see in landscapes, again in Borneo, where I've looked at this, that the actual pollinators that many crop species or food species depend on are much depleted in these oil palm landscapes. And they're much higher in forests. So you actually want to think about many of these values that are created in the landscape by having native vegetation.
And have you seen ways of integrating that into still a highly productive, commercially, I'm not saying that a forest is productive, but a highly productive, let's say, agroforestry system to integrate, to intervene, interwoven other species to push, or even multi-species? Of course, we have the syntropic side, which is very different than a monoculture. Have you looked at any of those?
I'm not so much an expert on the agroforestry, but I would say that there are good models in various parts of the world. So like in the island of Java, these mixed home gardens, they call them, are very much like multi-story forests. And I think if you look at satellite images, it's really hard to tell what's a real
forest start.
And it's these damar agroforests. So these are agroforests that have been created for growing resin, damar resin. So it's very hard to actually tell, if you're not an expert, that these aren't natural forests. So there's a lot of these very forest-like anthropogenic landscapes. There's also in other parts of the world, like around Mount Kilimanjaro, the Chaga people also have a very sort of rich agroforestry systems, multi-story agroforestry. So I guess many indigenous groups, many kind of traditional agricultural systems were aware also of the value of diversification because you didn't have these mass markets. This is something modern. So people learned to do what they needed sustainably as a community. And these systems were reasonably benign in many cases.
And do you see interest from larger agriculture companies? You could argue lots of the soy in Brazil is completely dependent on certain parts of the Amazon or the whole Amazon for their rainfall and irrigation. You could argue a lot of, I don't know the exact streams, but let's say from the Congo Basin probably feeds most of agriculture around it. The same probably in Indonesia, the same in many places, even the same, we could argue in Europe to a certain extent, like we're all in the same boat. Are they starting to wake up? Are they reaching out at all to people like you that have been pushing for this for a long time? Like, how do we use this knowledge, or how do we apply this in our super complex, super commodified supply chains, unfortunately?
I think there are positive trends, but whether they're quick enough, this is the challenge, right? You can see it as positive. You can also see it as frustratingly slow. I am aware of certain initiatives where some companies are interested in these things. I know people also working in banks who are starting to look at these as risks associated with the large-scale agricultural kind of investments. What is the chance of the severe drought or tipping points in the Amazon, for example? Exactly what you're asking. So I think people are starting to look at these things. So at the moment, I have one PhD who is looking at the effects of recycling of rainfall in the Amazon basin, and particularly from the perspectives of farm security, I think. And a lot of the companies that she's Brazilian, the companies she's been interacting with, I think they're actually quite excited and interested to hear about this once they're convinced that this is really a problem. Or potentially a problem.
And a potential way of at least acting. There's a lot of things, the climate is changing, carbon, and we have to decarbon, but this is actually, you could influence part of your rainfall or part of your drought cycles or part of your, and it's not completely out of your control because it's somewhere in the Netherlands or somewhere in Germany. Actually, it's in the same continent at least, or subcontinent.
Yeah.
So I think that's what makes water interesting as well. There is a very real, concrete way of acting. As soon as you, let's say the light bulb goes off, there's a very way of getting involved for almost anybody somewhere in the food and ag space. You are interacting with water, if you like it or not, and so you can get active. But I'm still surprised that it's not a risk factor. I just saw a report coming out of FAIR, which is a big institutional investor group, talking about the risk of water, and I'll put it in the link below. but nothing like water scarcity. And of course, there needs to be more regulation. And there's not a word about, or at least in the press release, there's not a word about any of these topics. There is a real risk of tipping points, and there's a real opportunity of these things as well. Not a word. It's great that they look at that and they say, of course, dairy is very water intensive and lamb farming as well, etc., but none of the recycling or let alone triggering rain is part of that language. I'll reach out to them. Let's see what they say. But we need groups like that are pressuring large, because they invest in large companies, or they represent investors in large food companies. Like, we need to report on water risks and water opportunities. But that still feels a bit far away at this moment.
No, definitely. I think there's still, we talked about it briefly earlier, that there's just too much people thinking in silos. If I'm happy in my topic, the other topics don't matter. But of course, a topic like water, it matters for everything. And it matters for everything in a big way. It's not a detail, it's fundamental.
Yeah, which also gives a great opportunity, because compared to biodiversity, or nothing against, obviously, which basically is nature itself, and us, and we're mostly non-human cells, and carbon and soil carbon or soil, and all of these topics are interesting for the geeks like all of us, and not necessarily the general public. But water touches anybody, and mostly us as well. And so I'm betting that there will be a much more potentially cross-border, cross-spectrum, political spectrum, across many. This is a topic we can probably find some kind of agreements on, or we're going to fight wars about, which we already do. In terms of accessibility, you discussed it as well with Alpha Low, and some of these big hydro dams or big river systems, why are they not discussing how do we grow more water, instead of arguing about the limiting source that slowly dries up, and it's going to be an endless fight in scarcity instead of the abundance. But that's flip I haven't seen yet many places, but I can see it. It makes so much sense to have that conversation, to really push the waters, to make it a central piece. And it's probably one of the cross-border ones we can agree on. Probably not on carbon agreements and things like that.
Yeah, I think that's challenging. But no, I was going to say, I think if you're a farmer in China, and of course there are a lot of farmers in China, and you have to think, where is your rainfall coming from? It's really coming from to the west there of Asia, and even in Europe. You really have to think about these large-scale processes much more. And it's the same in parts of Western Africa, in parts of South America. A lot of their rainfall is coming from elsewhere. And I think we're only just beginning to really think about these connections and what they imply. Okay, we've known about them for maybe 20 years, and people started to quantify them fairly well maybe a few years ago. But the policymakers haven't caught up with this yet. We really have to be talking much more about how our water is coming from elsewhere. And I would always say with the biotic pump, it's the forests that are upwind of you, but also the forests that are downwind of you. The forests that are upwind are bringing the water, but the forests downwind are drawing that wind to you. So particularly if you're living in a landscape with very little forest, you may be in trouble. Or if you're surrounded by declining forests, you may be in trouble. So there's a lot of people who will be affected by these changes in landscape in the future. And I think particularly places like China, there are so many people, and they're very vulnerable to this.
Yeah, so it's not even impossible to imagine, because in many ways they're quite forward thinking or long-term thinking, that they will start funding regenerative agriculture, food, agroforestry, restoration to the west, all the way to where the rain comes from. And that's probably a good thing. And it would be not absurd at all, just like they're doing the silk routes and trade routes. Like, you need the rainfall, and you need the rainfall to be starting somewhere, seeded somewhere, and get all the way to you, and then triggered. Otherwise, why bother?
Yeah. No, people will have to start thinking really big and thinking really cooperative. It's a challenge. But
both of those things are a challenge, actually.
We have to be optimistic. I think most people you talk to one-to-one, they find this common sense. So, I think there is opportunity here, because there's nobody against this. It makes a lot of sense, I think, that we all benefit from having a wetter, more productive land, right? And this is something that I do think is achievable. We just have to share this vision.
And there's some fascinating stories in India, on the subcontinent, which of course is much more than a country, of bringing back rivers. And really, I think the guy who brought back rivers, I don't know the legend, but I think the current count is 9. If we look at water stories of Zach Wise, we see updates there, and it's literally a whole landscape that came back to life because of water harvesting techniques, because of agriculture changes, because of natural restoration. And it's not, everybody always says, Is this also possible at scale? I'm like, I don't think you looked far enough east in terms of possibilities. But of course, because it's in India, we don't really talk about it in the West necessarily. We don't study it too much. But I think there are examples. Loess Plateau is another one in China and some others. But we need more. We cannot just have always those two, because that's just not convincing enough. And as a final question, we always like to ask, which usually lead to other questions, but if you had a magic wand and you could change one thing overnight, in one shot, what would that be?
I would make the climate community more open to these landscape effects, because I think for the policy agendas I'm trying to persuade, they have become the roadblock. In a sense, it's simple because it's just an opinion that we need to change, but we just need people to wake up to this importance of these topics. I think a lot of people are awake, but there's also this pushback all the time. I feel like I've been taking 20 years basically just pushing against people who disagree. And why are they disagreeing? It's common sense, right? This unwillingness to hear from some people.
So I think there is some people that have something to lose, because if you have built your whole career on CO2 equivalent, CO2e, carbon, then, and we're saying, actually, nobody is denying any of that, but there are other emissions and there are other pieces of land use and vegetation that have a large effect. How large? Let's see, but it's not insignificant. And it's the other leg of the climate stool, as I think Dr. Neon loved to say when he was still around. Like, it's a big piece that we're ignoring. But people have built careers on that. And so it's going to be difficult. Maybe, hopefully not with one funeral at a time, like Anastasia says. Like, slightly earlier would be nice, because we don't have time to wait for that.
No, exactly. I think I find it sometimes slightly frustrating that we're talking about saving the earth. And in fact, all I'm doing is revising yet another scientific article to persuade another tiny group of researchers that this is worth thinking about. It's like we should be really talking about this at a much bigger scale, because the opportunities and the significance, I do think, it's unparalleled, really.
And I think it's a perfect moment to wrap up. I want to thank you so much, Douglas, for the work you do, the work you have done, because you've pushed this argument, this conversation, not this one specifically, but you've pushed this really far over the last years. You've really been a bridge, let's say, between a few scientists in Russia and Siberia a few months a year and other places, to out of the physics world into the forestry world, into the climate science, and definitely wouldn't have been as far as it is now without you. And thank you for coming on here to talk about it. And thank you for an optimistic piece on forests and the potential, and of course, the risks and challenges and all of that.
Okay, thanks very much for the invitation. I enjoyed talking to you.
Thank you so much for listening all the way till the end. I'm really happy to have had Douglas on the show, and wondering, what do we do with this? Why is this important? Why is this conversation so fundamental? I think it's such an important piece to understand why it's so difficult for the scientific community to accept, for really good reasons, because of course there's a lot of, let's say, untrue stuff out there, a lot of new hypotheses that prove to be wrong. In this case, with the biotic pump, the potential is so enormous, and the research on the physics side is very compelling, that it deserves more attention, and it could be one of those crucial ones we look back 20 years from now. And I find it just very interesting to look at how it receives so much pushback and what can we do about it. Like, this is not a show about talking like, oh, this is an interesting story, we get a lot of pushback and that's it. No, this is a show about how do we do stuff. And that's an invitation to you, the listener, hopefully entrepreneurial in a way and excited about water cycles and hopefully building things. So if you are, I think we made a very strong case in this episode about the need for entrepreneurs and entrepreneurial people to start building things and showing things on top of this research and the data at a scale that starts to be recognized by policymakers, by investors, by insurance companies, by the general public. We really need to think big, and we are all part of this one blue planet, which is mostly blue and mostly water. And if China realizes most of its rain comes all the way from Europe, if Europe realizes a lot of it comes from Northern Africa, if Northern Africa realizes it, etc., 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 and we get a lot of more, let's say, we are in the same boat together. So if you're working on something, please let us know. If you know any stories of people doing things, please let us know, and keep banging the drum on the water cycle restoration, or come up with a better term, because this is one of the defining ones, maybe one of the defining stories of our era. Thank you.
Thank you for listening all the way to the end. For show notes and links discussed, check out our website, investinginregenerativeagriculture.com/posts.
If you like this episode, why not share it with a friend? And get in touch with us on social media, our website, or via the Spotify app, and tell us what you liked most. And give us a rating on Apple Podcasts or Spotify or your podcast player. That really, really helps us. Thanks again, and see you next time.